So now we're moving on to segments and midpoints. By the end of this screencast, I want you to be able to really gauge yourself, rate yourself from 1 to 3. 3 as in you really know it all, 1 you're still clueless, on these two different postulates that we're going to talk about. 1, I can use the segment addition postulate to solve for missing values. We'll do some examples and go over that. And then 2, I can use the definition of a midpoint or a segment bisector to solve for missing values. So we're going to be doing some different algebra, but with geometric figures and some terminology. So by the end of this, you should be able to rate yourself there. Getting us ready for some of that solving, we're going to do a little warm-up. So I'm going to have you pause it, solve these two problems, and then I'll actually quickly kind of show the work to get to the answers that you should have. So you can go ahead and pause it now. As you solved it, you should combine like terms. Oops. And then you would subtract the 2 from both sides, which gives you 7x equals 42, and then divide both sides by 7, and you get x equals 6. With the second one, you would want to get all of the x's over onto one side, all of the constants on the other. It doesn't matter which side the x's are on. I personally don't like dealing with negative x values, so I would subtract the 2x from both sides. I would have 16, and then 4x minus 2x gives you 2x, and then the minus 8, to then add the 8 to both sides, so you're getting 24 equals 2x, divide both sides by 2, and you get x equals 12. So that type of solving algebraic problems are what we're going to be doing with some geometric stuff. So little notation, we have that segment AB, it's 7 centimeters long. If we're talking about the segment itself, we learned that we label it with the line above it, 2 capital letters, and then the line over it. Since it's a segment, we don't have the arrows above it. That would be for a line. If we're talking about how long that segment is, so the length of it, we don't put the line above it. We would just say AB is 7 centimeters. So when naming the object, you use the bar, but when talking about the length, we don't. If we take a look at this problem, they're talking about how far something was, so it's like the length. So we know that AC is going to be those two little parts combined to be 7. We don't put the bar above the AC, but to actually answer the question, how far is house A from house C? And it would be 7, most likely blocks. I don't think we're talking miles. It didn't specify. It did say blocks, so we know it's blocks. The segment addition postulate is saying that if you have a point between a segment, then those two parts have to add up to be the whole thing. So what we're saying here is we have that segment AB plus, and it looks like BC. That gives us our total, in this case it was green, AC. So the two parts make up the whole thing. And the only way we could ever compare these is if it is collinear, meaning they're on the same line. You cannot do something like maybe here's B and there's A and there's C. And just making up some numbers. You can't do something like that. It has to be on the same line. So using that postulate, segment addition postulate. If we had to find the length of AC here, we know we're taking this part plus that part, and we're getting 11. Now we incorporate some of the algebra here. Same exact idea. They're telling us that x plus 2 is this little part right here. Then they're telling us this part is 4x. So we know that the total has to be this 42. So the two parts add up together to be the whole thing. So we're taking x plus 2 plus 4x, and that's going to equal our 42. The two parts equal the whole. You can go ahead and continue and solve that. Pause it if you need to, because I'm going to quickly say you combine like terms, you subtract the 2, and then you get x to be equal to 8. But did that answer the question? No. It says find xy. Well, we have to take that 8 and plug it in right there. So then 8 plus 2 means that xy is going to be 10. So I actually wouldn't box off that. xy equals 10. Hold off on the practice problems. We'll do those together in teams. So skip practice 1, practice 2, and then let's take a look at midpoints and bisectors. So a midpoint, obviously in the word midpoint, it is a point which splits a segment into two smaller segments of equal length. So an example of that might be, here's a segment, we'll say TS, and if C is the midpoint, then that's saying it cut it into two equal parts. And the way we would say that they're equal parts is we would give them some sort of little symbol that's the same. So sometimes you'll see one little tick mark. If this one had 2 tick marks, then you would have to have this one have 2 tick marks, saying that those are both equal segments. So a midpoint is in the middle of that. Then we have a segment bisector, and it's a line, a segment, or a ray which meets a segment at a midpoint. So there's all sorts of different ways that can happen. So we can have a line segment, and right there in the middle ends up being the midpoint. Maybe it's possible that you have a line going through there and it cut it into two equal parts. Maybe you could have had a ray. Maybe you could have had another segment. All of those work. So maybe we'll just label some of these. So then that's an example that has a line bisecting, so cutting in half a segment. If you take a look at these next 3 examples, you're going to do those in your teams, and then we'll go over them as well. See you soon.